Now I should be heard. There we go. Well, what was happening? Some genius put it on. I hear myself multiple times, so sorry for that. I put it on monitor only because I was testing some stuff and I need to hear myself in headphones. And I put it into monitor only, so it went, yep, I have sound. No, stream is not getting it. So, well, I had to change that. Before we begin, I'm gonna post it on social media and all that jazz. Okay, this is gonna be a bit of boring stuff, but well, sorry for that. I'm gonna do a proper intro as soon as I do this. Uh, okay, let's not forget. Hello, Gaurao. Hopefully, I said your name correctly. One more. One more post, and I'm done. Here we go. There is so many social media I partake in these days. It's kinda a lot. Here we go. Hopefully everything works. And how is everybody? Before we really begin. Yes, I need to do that someday, Joshua, but I just haven't done it because I didn't just post on social media. I also post on some Discord servers and stuff like that. So I need to automate all that for a couple of things. Now, before we truly begin, to still open a couple of terminal windows and do a couple of logins. Great, this VM is dead. Good job, me. Well, how is everybody? Hopefully everybody's great. Okay. And SSH isn't working. Great. Journal, CTL. No, it's not firewall. It's VM. They have a network. It's SSH actually not starting. Dash FU SSH. No host keys available. Joshua, do you know how to generate host keys? For some reason, it didn't generate during install. Okay. Oh yeah. Let me generate on both virtual machines and have two. And both of them need to work since we're doing things. Journal ctl-fu ssh. Yep, same problem. SSH keychain-a should work better than just that. Dash keychain-a. There. So now I should be able to SSH into those two virtual machines. Oh, I still can because I forgot to start the SSH server. Start SSH and sudo system. Start SSH. There we go. And um, uh, complete pane down SSH to the experimental one. That would be okay. Before we begin, we're gonna also test out one of my next screens I have prepared, and I will be right back. It was getting a bit chilly, so I've done a bit of change to the cooling system, as I like to call it. So now, transition back. Now, before we begin, I have to say something to people like Joshua who know me as the guy with Linux. Today I'm not on Linux. I'm streaming you from Windows for various reasons. But for one, this machine doesn't have Linux installed. So let's say hello to let's say hello to Windows Terminal as staged into two Hyper-V VMs. Yes, I since I'm on Windows, I use Hyper-V. And moment, please. Yeah. Okay. So, okay, I have to still do an intro. I forgot that to do an intro. So, proper intro, of course. Back to this. Hello, everybody. My name is. Okay. I'm gonna be shortening this stream down for a bit for YouTube publish. So that's why I'm trying to do an intro. Hello, everybody. My name is Bigpod, and today we're gonna be doing some exploration of overlay networking, containerization, containerd, maybe even some LXD. If you're up for it, join for this long video, or if you're right now in the chat, say hello in the chat. This was streamed on 21st of January 2023. And thank you for watching. Yeah. Now back to the content. Now this is Windows Terminal split into two panes, and Joshua Lee pointed in the chat, it is an Ubuntu host image, yes, but it can be whatever you're most comfortable with. As long as it can run some sort of containerization, you should be able to follow along with this video. I'll be using Containerd as it is lower in the stack of containerization, and it's actually a lot more configurable, which could be a blessing or a curse. We'll see. Of course, because it's me, I tend to forget things. I forgot to install Containerd into my two basically brand new VMs. So let's quickly install in both of them Containerd. And the easiest way for Ubuntu to do it is using Docker repositories, ironically. So let's update and install some stuff. Sorry for the name for host name of both systems being same. That's because, well, it's a copy of what one system is copy of another system. I'm lazy, as you probably figured it out. All right, I'm just copying stuff. So again, how is everybody? Having fun today? And I hope you're gonna have fun in this stream / video. I will try to explain and do things correctly, but we'll see. So we've updated, so now I can do sudo apt install containerd.io. I'm just gonna copy that. Here we go. Now, containerd should be available on our systems. We can check that by simply executing command ctr. There we go. This is containerd's client application, but it isn't exactly the best. It's an unsupported debug and administrative client for interacting with containerd daemon. So there are better tools for it. Let's install nerdctl. And it's not nerdctl for nerd, it's nerdctl for containered ctls. As you can probably guess, it's this part. They needed a cool name, and this came out with it apparently. So how do we install containerd client called containerd for nerdctl? Simple. We go to their GitHub page and we pull down a file or appropriate for your version of system. You have for FreeBSD, apparently for Linux and Windows. Cool. Let's try this one. I'm gonna copy the link on their GitHub page, and I'm gonna just simply get there. Now, if I could remember how to untar a file, that's what I always forget, even though I do it every day. tar-xf nerdctl full. Let's see what we have in bin. Okay, this is everything, clearly everything that we don't need. Bin libexec. We're gonna use their basic one for now. So that would be their other link, the nerdctl 1.1.0 Linux AMD 64.gz. The what I installed is the full version where you have containerd, CTR, buildctl, buildkit, and everything else you see listed here. This one should be a bit smaller. r-xf nerdctl. Here we go. And we only get 3 files: container, rootless setup, and container rootless, and nerdctl. We're gonna just move nerdctl to /user local bin. So it's automatically in our path. We're gonna just copy paste this. Good job. There. We're gonna, why am I doing that? Gonna copy this, and we're gonna copy this. And now nerdctl. It will complain that rootless containerd is not running. So what's the solution? sudo. And there we go. This is our fully featured containerd frontend client. It's quite as featured as you would think. It's almost as featured as Docker client is, if not actually more. And it's a great alternative if you don't want to use Docker and maybe not want to use things like Podman. So we have containerd, we have nerdctl, but we need something else. What do we need? We need something called CNI plugins. So we're gonna pull CNI plugins from their GitHub page for Linux AMD 64. So what are CNI plugins? Since we're gonna be talking about CNI a bit today, and possibly in future when we actually might look into CNI itself. Let's just pull CNI plugins. So CNI is essentially a spec for container networking. So simply it's how containers should be networked, or how things should network to containers, stuff like that. It's defined in this spec. And these plugins are basic plugins for containerd and I think other things, so they can do networking according to CNI. Without these CNI plugins, nerdctl and general containerd can't do networking. Now we're gonna need to extract those into a specific directory actually. So I need to find the right. So we're gonna have to start. I'm gonna actually create another directory. If this is made in exactly the same way that is, or actually I have a better idea. Tar /opt /cni/bin cni. Oh yeah, am I genius? xf cni dash. What am I forgetting? I'm gonna just copy a command from GitHub. I'm lazy figuring it out. There we go. Oh yeah, sudo mk here dash p. We have to first make this busy directory. Then boom, sudo. There we go. Let's copy this command. And let's copy this command. Oh, I forgot first to download. Good job me. So right now you see the full-blown how I work very badly apparently. Sudo. It does. It's just not pulling in the exact same way as you would be used to. So are you using nerdctl or CTR? Because nerdctl should do it automatically for you, but containerd CTR doesn't. I'm gonna actually show you that, because CTR, if you do images, you will see the command pull. But right now you probably think, so in Docker you would do pull Ubuntu, for example, or Fedora, and it will go to its default Docker hub, and it will just pull things, right? Not in containerd. Container doesn't have a default. If we do that, of course, with sudo, it has unresolved reference. Why? Because that's not automatically patched to Docker Hub. It is just whatever. This is as Fedora. It should be somewhere local then, and even not that. So let's look at what nerdctl does. I pull Fedora. Now this to my images. Image. This should pull, if I remember correctly, and it does. And now this is the right link you're looking for. This is the right name. docker.io/library/Fedora. Now let's use ctr I pull, and let's pull down Ubuntu. And with tag latest, with sudo, of course. And as you see, it's actually pulling it down. Why is that? Because you had to actually say the proper path to Ubuntu. It's like if you're using your own registry for containers, and you have to actually have a specific path. You can just say Ubuntu and it will know to pull from your own registry, only because Docker, Podman, and even Kubernetes all have as a default set to Docker Hub, because it is by now considered default registry, even though it is really not. And I actually go so far to actually replace and actually in containerd set that, I don't know, my registry.bigpod.sc, which actually exists, would be the default registry. So I could even do just registry slash bigpod slash something, and it would pull down the image. Or you can go just Ubuntu, and if I had an Ubuntu image inside library, it would go and pull it down. Does that make sense, Joshua? I'm probably gonna cut this stream a bit more than just that, and I'm gonna probably make it into some shorts as well. You're gonna see some proper mastery of uh, this sort of stuff from me now. Gonna try at least. Now, okay, so we have CNI, we have those sort of things. Now let's try and start a container. Oh, good old KVM joy. Yep. Now let's start a container. We need to know that we can do that. So we're gonna first try with CTR. CTR run. Image ref must be provided. Image ref would be this. Let's start another Ubuntu image of latest. We haven't provided container. This would be in Docker terms name. Test alpha. Of course, if we don't do sudo, it won't work. Since it's a root full container, as I like to call them, it has full root privileges for the daemon. Image not found. Huh. Oh, haven't I? Oh yeah, I haven't pulled it here yet. CTR pull. I pulled it on another server. Genius me. So, any questions so far? And run. Latest. Oh, I'm not sure. Never done that actually. Sorry, Alex. But as you can see, we have no prompt at all. This is actually good because I forgot to set it into a TTY mode. Yeah, where K0s, yes, K0s should use containerd. Most stuff currently use containerd. You should probably look into how to point to the right, what is it called, right socket. Currently, the socket for containerd is at /run/containerd/containerd.sock. It has a default location, but K0s might not have it as a default location. So check where the socket is and set it correctly. As you can see, we don't have a prompt. Why not? I forgot to set it as a base. I forgot to set it into TTY mode, so it would actually think it needs the prompt. So if we go, let's say ls, we get a list of files. So how to set it into TTY mode? So we have a prompt -- TTY should work. O -E should work, I think. Oh, interactive. -I. Oh, it is -TTY. I just haven't placed it in the right location. And here we go. Already exists. So let's go with this. Bravo. And now we see we have a root user at stream. Why at stream? That's because that's the name of my virtual machine. And we still have root file system of Ubuntu that we install. I mean, we created as a container. Now I'm gonna just exit this. We're back into our main namespace. Now, so today's topic started as overlay networking to connect your containers. So let's talk about what overlay networking is, first of all. Overlay networking is a network on top of your other network. So that would be essentially how VPNs run. VPNs are essentially a network on another network. Or if you're familiar with Kubernetes, Kubernetes actually uses overlay networking to do that cool things that when you have two pods that they can communicate between each other, but they don't actually, but those IPs aren't on your network, on your main network, or they aren't like, and even those IPs aren't accessible from your main network. That's what that is what happens when they use overlay networking. And same thing is done by Docker Swarm, which I believe is now sunsetting. So so now the question is how to establish our own overlay network between 2, 3, 4 Docker hosts, containers hosts, Podman hosts, or even mix of them all together. So we're gonna actually look at the technology below that. So we're gonna actually construct one ourselves. So I'm gonna start by looking at things in Google because I forgot to save some links I created. There is one I particularly saved. Yep, this should be the one. Yeah, I have no idea how to exactly to do this. So all I've done is I've did a couple of things. I read a couple of things, so that I know that I can actually do it. Now, let's begin, shall we? With setting up an overlay network. We're gonna be using technology called VXLAN. So it will be VXLAN. Some of you may know it. It's a virtual LAN. You can create a virtual LAN in Linux. So we're gonna start by first creating our virtual LAN interfaces. This you do by doing IP link add. Let's name our interface VX10 of type VXLAN with ID 10 of group. Let's use 239.1.1.1. It uses a multicast, so it needs an IP of some group IP of some sort, and destination port of 0, and device on which it will communicate, on top of which it will create this network, this overlay network. That's why it's called overlay, because it's a network on top of another network. 80. We're gonna copy this command because we're gonna first check something out if it's really 80, and we see it is. This is our 80. Now we create an vx10 type LAN, that vx10 of type vxLAN, and IPA. We see here is our vx10. It's currently down. So now we're gonna do exactly the same thing here. Now we're gonna also want to set up a bridge. Why do we want a bridge? Very simple. If we don't have a bridge, we cannot connect our containers to that VXLAN interface. Essentially, that's how all of them do it. So if actually do not have anything here because currently it's not available, but let's try and use nerdctl to create a container. Sudo nerdctl run Ubuntu. Of course, I should probably interact to TTY. So now we have our own network, our own image in Ubuntu image. And let's try and ping something like my standard target is ipv4@google.com. Ping doesn't exist, of course not. Let's just update our apt repository. Update. And it does, which means networking works. So there must be some way to connect that it connects. What happens is nerdctl established a bridge between our main system. So this is a VM, is the in this host or main system, and that container, which is what we're gonna do ourselves as well. And you see, this is the fourth one, the nerdctl 10, which is what it uses. This is the bridge actually, and then it set up its own VXLANs or similar type of interfaces for it to connect to stuff. Now, since we have our VXLAN here, we're gonna create our bridge next. IP link add bridge VX10 of type bridge. Of course, sudo is useful command. And we're gonna just copy this command over to our server. We need to have exact same settings on both sides of the situation, on all machines really. Now we need to link them. But specifically them, I mean link the LAN with VXLAN interface with the bridge. So VX10 master. So I don't know why it's called master. Maybe some of you know in the greater chat window, IP link set. Now we're gonna just copy it down, and next we're gonna set both of them to status up. Sudo IP link yeah, have a good meal. Set VX10 to up, and just to make it easier to copy, we're gonna do IP link that br VX10 to up. And I'm gonna copy the command, and of course second one isn't working. Boom. Same here. Now we need to connect our bridge to our containers, and this is where my knowledge will start to falter, since this is when my how to call this my research I stopped. I know what I need to do, but not exactly how. I know we need to go and I need a CNI file for network. I don't know what to do with it. So let's go and open the right files right now. So we need to go to /etc/ I believe it's CNI netd. Yes. Now we have a single conf list file here. nerdctl bridge conf list. So let's open this file up. This is how nerdctl's default network is set up using CNI. This is the file that is the how to say this, the main way to define, according to CNI spec, how to define a container network, or a connector for that network, I think. Or yeah, I think a network. Let's try and create a network with nerdctl. sudo nerdctl network. So you see, we get a bunch of help, and one of them is create. Let's create a network. Let's name it. How should we name it? Stream test. Great. Now we get an ID for the network. Let's see what this did in net.d directory. We have nerdctl streamtest.conf list. Now this file you can copy around on all your servers to get the same things. So, but let's try to see if we can get more out of it with using help. We have driver setting, we have gateway setting, we have help, which we just used. We have IP range. We want to do allocate only a sub range of some sort of range. We have an IPAM driver, which is how IPs are dealt out. We have IPAM opt, some settings for IPAM drivers, and have a subnet to set. And most of this stuff is really defined by CNI spec. So let's open that file up now. So it's which version of CNI, name of the network, nerdctl ID, nerdctl labels, and then we go to plugins. This is what we installed at the start when we were installing CNI plugins. We had to install the bridge plugin. So we have a bridge network. So this means we can connect to a bridge. And we know what our bridge is called. BX10. I guess this will work. I don't know. That's where I was just reading CNI documentation, but nothing else. So I could be totally wrong here. Is gateway. Let's set it to false. I think this will make it a bit more secure, or not secure, but not make it be a bridge to a. So it knows that it cannot go to internet through this, as far as I know. So gateway, where the gateway is located, we don't need that. But we do need a subnet with subnet to use. 10410 is okay. Routes, I don't think we need those because we don't have any, but we do need type host local. I do remember reading about that, but I can't remember what it is. So let's ask CNI host local IPAM. So host local IP address management plugin is basically a way to give how to give IPs out. And it does it by having a local database. So we also have firewall. Now this stuff is actually now important. So we're gonna save and exit, and I'm gonna just get this file out, because we're gonna do a very important thing. We're gonna copy paste it, sudo nano /etc /dni /nib.d /streamtest.conf list. And first we're gonna create actually. Dorian, you're not dreaming. Yes, it is a Bigpod stream. I am Bigpod and I stream. So it's a stream, it's a Bigpod stream by Bigpod. However you wanna call it. And it's just as horrible as all the previous ones. So we're gonna create a directory for etc dni nib.d. And now we can create our file. We're gonna save it. We actually don't want to change anything. And now if we go sudo nerd ttl network list, we should get our stream test network. There it is. This is where I know that I now can do things with it. But we're not there yet. We still have to get it to work. So, any questions up until now? Or any questions in general? Please let me know in the chat. Thanks. That's nice to hear. So now you get even more of me if you really want to listen to me. So if you have any questions, just type them in chat, and I'm gonna continue with now try to run a on one side an Nginx. On the other side, I'm gonna try and run a Ubuntu simple Ubuntu client, Ubuntu image, and install curl in it and open that and just get that what is called that Nginx to pop up. These two are two completely different servers. Reason they have same name is because I just copied one of them. So if you look at an IP, we see have a bunch of, but not here. We have just 4, and we can see that their IPs on 80 are completely different. So they are different machines, different VMs. I just made a copy because I was hurrying things up and I didn't change the host name. Bear with me for a second. Okay, let's continue. Again, if you have any questions about any of the topics we are talking about, or we already talked about, or anything in regards to containerization, Docker, Containerd, or any of this stuff, please let me know in the chat, and I will try to answer it. Okay. Now that we have network, let's in on the stream, what I call stream 1, let's create our sudo nerdctl run nginx. This will run nginx as a pretty basic server. But I made a mistake. I should run it in a simple, in a daemon mode. So D. Sorry, I'm a bit sick. Okay, we have this ID, which is really a replacement for our names. We didn't apply a name, so we're gonna just do an inspect on it. This is how much I know, mainly because I actually do this stuff with Docker. Not don't think I know about the nerdctl, just know with Docker, so I can guess nerdctl is the same thing. So we actually want to know this IP address 10.4.0.5, which is wrong. Why is it wrong? Because we forgot to apply the right network. So we're gonna go again, dash network. And did we call it stream test? Now this should be in the right network. We're gonna see that by the right IP. And oh, yeah, it's 10.4.1.2. Now that server should be running in 10.4.1.2. We're gonna copy that and we're gonna go sudo nerdctl run -it stream test. Of course, make network, so network stream test. And we're gonna do Ubuntu. We should get a nice bash shell, and it shouldn't have curl installed. So we're gonna go apt update, and it doesn't have oh yeah. Do you know why it doesn't have curl or networking? Because I, as a genius, forgot to that Ubuntu doesn't have curl inside, and we cannot do that without updating. But we cannot update because this network doesn't have direct access to the internet. So we have to have another network connected to it, but right now I'm not gonna bother with that. While there is Ethernet on both virtual machines, Ethernet doesn't, because of the way I created this network specifically for container, it doesn't get direct access to internet, which isn't a problem actually in most cases, because your container should be built out before you even start it. But I forgot that that Ubuntu doesn't have curl in it. So the right answer is we're not gonna use Ubuntu. We're gonna use and I'm already angry at myself that even know this. We're gonna use Alpine. It will pull Alpine. Does Arch Linux have curl in its default Docker image? The OCI image. Correct myself. Oh, wait. You don't have curl either, but you have ping. Good job, Alpine. It has ping, not curl. Good job. Let's try Arch Linux. It will pull Arch Linux from Docker Hub library. And let's see if this has curl. And this is quite big. Yes, it has curl. Now, let's remember what IP address we have. http://10.4.1.2. And there it is. There it is. Welcome to Nginx. But I have a sneaky feeling this wouldn't work if it was first try. Because I know how host local works. So I wanna test something before we jump into congratulating ourselves that we did a good job. Let's see what IP our latest image has, our Arch Linux image. Let's exit. And let's inspect it. So first we need to actually find what its name, or more likely its ID is. So sudo nerdctl ps-a. And we see our Arch Linux image has this ID and this randomly assigned name. So let's copy this container ID and let's just quickly inspect it. And we get to know that there is no networking whatsoever here. What? Oh yeah, forgot to do. Oh, there is no network settings here. What? Wait, what? This is even worse than I expected. This was something wrong here. I'm gonna be totally honest. Let's try with our Alpine image. Also has no network settings. Wait, what? Why doesn't it have network settings? This one does. Why? If you have any questions, while I question myself a bit, please let me know in the chat. Why this doesn't have network settings? What did I fuck up? Containers. This is this while I'm doing this is actually something of a learning opportunity on for me for my job. Actually, I do high level stuff on containers, so I'm trying to learn lower level stuff so I'm actually understand containers better. Why did this happen? Oh, I know. I think I know. I think I might have underestimated how well I can reuse stuff. What we're gonna do, we're gonna just grab this because we know it was accessing a network. How do we know that? Let's create another container. We know we set up a network and it is Arch Linux. And we know it has a network because if we curl http://10.4.1.2, it will get it, and it will be from here, because now let's not inspect this container, but let's pull logs from it. For this work, we get two HTTP GET requests on HTTP 1.1. We know that this is this because if we follow, so we get a stream, we get this. And now we even know what IP it has. 10.4.1.5, and before one had 10.4.1.4. Now, my question is, if I create two more images of Nginx, will I get an IP of 10.4.1.4? Or if I create three, 10.4.1.5? 1, 2, 3. And let's look at this one. Docker nerdctl with sudo inspect, and let's inspect this one. And yes, what we got was 10.4.1.5. And now, if things are working according to a networking spec as they should, let's first see this. IPA. Oh, really? Yeah, this one has IPA as well. Cool. Now, if things are working according to networking specs, this shouldn't start Nginx. Shouldn't get Nginx. And it doesn't, because there is no port 80 active on 10.4.1.5, because for this guy, 10.4.1.5 is itself. So why does this happen? Anybody can have a guess in the chat? Reason is pretty simple. At least I think it is. I'm gonna wait a bit before you catch up to me. Before I reveal the... Alex, you're pretty close, but not exactly. You are, but you're pretty close. The reason is we used what is called as IPAM, IP address management. So this is the way IP addresses should be managed. This is standard thing. So nerdstl trimtest.conf list. This is what we first edited, and here it is, IPAM. This is what we need to know. And oh no, ranges. This is the subnet. We're using same subnet on both sides, which we should use. But we're using an IPAM plugin type of host local. Now, host local IPAM allocates IP and IPv4 and IPv6 addresses out to a specified address range. And we didn't specify any address ranges, which would suggest that this whole subnet is for use, which it is. Problem is that the two host local databases, what each node contains its own host local database for this IP range. They have no relation to each other, which means there is no way you can make sure to give with this plugin to ensure this VM and this VM give different IP addresses. If you want to give the whole IP address range, which would be good if you have, let's say, IP address range of 20, and you want to give any random IP address. But you can, this is the important part, you can take this VM, and go with range here, range start, and let's say go with 10.4.1.10 to range int let's say 50. But this has a very bad side effect. What is that bad side effect? Because on this server you would actually do something like same thing, just select different ranges. So let's quickly select different ranges here. So if we go here, jump here, let's go with 100 to 140. What's the problem here? If anybody can guess, it should be pretty obvious. We are effectively capping our each machine, each node to specific number of containers. Yet we don't know how many containers we might want to deploy on that machine. We will have to design our network in such a way that it would allow us to, that each machine can only have, let's say, 40 systems on this one network, which can be pretty problematic. So how do we now solve that problem? CNI has to be the solution, right? And this is just an IP management issue. So IPAM. And IPAM uses plugins. Yeah, you can make a bigger range. Yeah, it becomes less of a problem, but there is a smarter solution to that. This is a pretty, let's not say dumb, but pretty basic solution. That's why neither Kubernetes, which uses this type of thing, and something else, and we're not going to use any normal networking solutions, technically speaking. First option is use a custom DHCP, but it would need us to do one thing. Same thing we will need to do with our with the other solution. Since CNI already has a DHCP plugin, so you would think that now, since we have this, now we just need DHCP and it will give out to both computers, right? Both nodes. And there is no shared IPAM. CNI in its basics doesn't have any knowledge of how much shared it is. It's just a spec about how to do networking, and how you do that stuff on it is all based on plugins, and there is no shared, no base plugin that understands multiple nodes. Even the DHCP plugin is made in such a way that it only allows for a single machine. Why? Because it uses a daemon socket. So the answer is, I've talked about plugins with CNI a lot. The answer is write your own plugin, which is pretty easy to do in Go. CNI has examples. So all you need to do is create an IPAM plugin, which can be essentially SK remote server, remote API, or remote DHCP for an IP. The most basic for multiple nodes would be have a basic API which has a database and grabs IP from the database that is empty and returns it to the plugin. which then just puts it onto the machine. That's all it needs to do, as far as I understand CNI. Yeah, there is no shared IPAM at the moment, but you can make one. As far as I know, Kubernetes has its own Kubernetes. Different Kubernetes implementations of the networking have their own shared IPAM plugins, but they're far more complexer than what is needed for such basic overlay network, and are very much coupled to the whole networking stack they operate in. But this is a pretty simple solution. If you want something, of course, if you're just home labber who wants to do something like this, have a shared, have all the containers pulled into its own networks. Yeah, Canico and stuff like that. Yeah, I think it's Calico, but yeah. Um, you can do it with ranges, but if you want to have something a bit more sturdier, more less brittle, like this is pretty brittle because of it has defined ranges. Something like using my idea doesn't have that kind of brittleness. It's just a simple API. While I will not be making it in this stream, I'm not that adventurous, since I'm not actually prepared to do it. That's the only reason, really. We could in future look into creating such a CNI plugin. Now let's before we actually continue, let's test our hypothesis if range star generation even actually gives those IP addresses. So because we know what happens, we're gonna start a new container. I could just inspect this container, but we know that on this server, for some reason, network settings don't get applied. I don't know why, but on this one they do. So let's just do logs on this server, on this container. There we go. This is our previous. So now we're gonna just do curl http s http colon slash legend. If I remember correctly, it's 4.1.5, and we get it. Reason is now this one is 10.4.1.100. As we said, the ranges to be on the second stream's VM. We said it to be from 100 to 140. And now we have our own. Now we have separate IPs given. So if you know you're gonna have only 40 IPs in a given network on each node, you can do that. But I would not say that. I wouldn't say that that should be a good solution for if you have a more professional deployment of this kind of an overlay network. If you have any other questions, please let me know, because we have already done what I set out for the stream to do. So, and I'm looking for any questions and stuff like that. By that I mean a server, a VM, whatever you wanna call a VM, a server, one node VM server, basically a an operational a system on which Docker, Podman, or uh, containerd runs and runs those containers. That's a host system. You can have some run host systems as VMs because, well, you can then move them around or you run them in cloud. Any other questions, let me know. And before we continue, I'm gonna grab a short pause and let those questions stack in the chat. Be right back. Okay, I'm back. Now let's see if there are any questions. I see that there are no questions, and we're about 1 hour and 19 minutes into the stream. So let's talk about a bit about the future of this stream series. I plan to do more low-level Kubernetes learning experiences for myself and for others. So I plan to do stuff like low-level stuff like how namespaces work. I plan to see how namespaces work. I plan to see how storage architecture, how even how Docker registries work. That would be interesting to see. I know a tiny bit, but I don't know a lot. Maybe we could make a tiny Docker registry according to Docker registry v2 spec. IAC, please remind me what that acronym stands for, Dorian. So one of the streams I plan to check out how infra's code. Yeah, I'm not that good at infra's code as I actually don't work in the infrastructure. I am a software engineer. I work with software engineers, work with containers on that front. That's why I actually want and need to know low level things. So one of the things we're gonna look at regarding namespaces, I plan to, for those who know Kubernetes, know what a concept of a pod is. Pod is basically multiple containers that are like one. They share memory. They have a shared memory. They have shared network. How that works, we're gonna check out it. And I know a smidget, and I know it's how they share networking. Yeah, we could. As you see, my logo has BGP on it, and I've been asked multiple times if I know what BGP route, if I have anything to do with breaking BGP routers. Oh, hey, Yannick, you came right when I'm preparing to finish, but you might be interested in this. So I'm doing more and more streams about containerization, low level looks at things. So I don't know how much you learned of containers as of late, but you might be interested in the technology below the surface stuff like Docker. And today's stream might actually be interesting for you to rewatch from start, as we're talking about overlay networking. So basically, networking, how to connect um, image containers and even VMs across multiple nodes to get into a separate network. It's pretty nice technology. It's actually VPNs are a type of overlay network, actually. And why it's called overlay network? Because it's a network on top of another network. So for future, like one of the streams is gonna be about how pods work, as they're actually pretty interesting. I know it's all about Linux namespaces, how they use Linux namespaces to share certain things, but not other things. So we're gonna look at how that works and maybe even reproduce our own pod system in containerd. Or we could go even lower, run C. No. That I would have to then learn how to write a proper OCI spec file. I'm not sure I can do it, but maybe we could learn that. Another thing we need to learn is an OCI spec. That's OCI spec file is how container is actually, like, how container works. So that's another thing we should learn, since it's a extremely low level thing about containers. And I also have other things I want to learn and share with you, share my learning experiences with you. And I even have an idea for end project once we learn all these things. And that end project, and I know how well I'm with projects and streams. So it would have to be done in low amount of streams, that end projects. What if we made a poor man's container orchestration, multi-node container orchestration tool? So think a replacement for Docker Swarm. Docker Swarm is like Kubernetes, but a bit more basic. So what if we made kind of Docker Swarm, just a lot crappier and made by me, so not that great. And we can implement our CNI plugin. We can do storage on a more higher scale, like kind of like Kubernetes does. And we're also look into Kubernetes low level stuff, like how storage works. So join me on my next streams. Might do one next week. If no, I will try and do one next week, because then I'm gonna get complacent and lazy otherwise. So now let me just do a bit of a empty space then, because I'm gonna be cutting this stream up a bit into a more coherent video to post on my channel, and maybe cut out some special parts, like me trying to figure out why there is no network settings for YouTube Shorts. That's a thing. Yeah, overlay fast. Yeah, and we might even try. Maybe we could try and do something like NFS as a backend for our container orchestrator, or something like, I don't know, some cool thing they already have. Like maybe you can use Samba as our basic thing, or I don't know. I'm gonna just look at if there are any cool things Kubernetes uses for storage. You could look at that as well, like different storage types. They have persistent volume types. Then they have some really cool things there. We could maybe use, I don't know, OpenStack Cinder as a basis, or Ceph RBD as a basis of it all. I don't know. Huh. Yeah. FAT32 over the network. That could work. So since if we're gonna have a multi-node, multi-server container orchestrator, we need to have something that can do storage over multiple servers. Like can get storage from any server, not just from local. That's why we want to have something like NFS, which is what I use with Kubernetes. And I know it's not a good thing, but it's my own home lab. If it crashes, it crashes. It crashes a lot, not to NFS fault, but to fault called Bigpod. I like to tinker with it and break. But yeah. So now for all the YouTuber things, all the YouTuber and social media things. Oh, wow. I wanna use Ceph. Well, does it work on a single node? That's the question. Does it work on a single node? That's or do you need multiple nodes? Because I have on a single server, single storage server. But of course, VMs are a thing. So if we're gonna use, so then we need multiple storage nodes. So I guess VMs to the rescue. I could lash all my computers into VMs, create them VMs that are just for Ceph, and we can set up a Ceph cluster for one of the streams that actually make it work with our with Containerd as a storage backend. That would be an interesting stream. And that would be from that department. They some people like to have the how hard could it be. That would be that type of stream. Those are really fun, as always, by any streamer. How hard could it be? Many times the answer is harder than you think. So now for all the YouTuber things. Thank you for watching. Don't forget to like, subscribe, comment in the comment section down below, and click the bell button down there, down here. You need to click it, otherwise you won't get notified when I go live or upload a video next. And that's very important because you want to get notified, right? Also, you need to watch videos to get notified as well. So, yeah. This wasn't good, was it? Let's try again. Let's try better again. This I want to do one for a piece for a video, so I don't have to record it again. So let's try a better one. This is my video recording process live. When I try 10 versions because I didn't like the previous one or anyone, and then I just hit my wall with my head. Thank you guys for watching. Don't forget to like, subscribe, and comment, and hit the notification bell so you get notified. Thank you everybody for watching. See you next time. Now we're out of the YouTube recording mode. So yeah, if you have any other questions, let me know in the chat. Yannick, don't escape just yet. If you have any other questions, hit me in the chat. I'll be here for probably another 10-20 minutes, maybe. There is still a thing or two I need to think about here on stream. No, I can with fair certainty say that most of my viewers are subscribers. I haven't checked yet, but I think most of my viewers are subscribers because, well, when you have one viewer and 291 subscribers, yeah, there is a good chance that person is a subscriber. So yeah, really, please subscribe. I need that. I would like to get to a bit better number when it comes to subscribers. Yeah, that's what they do, just to get that algorithm thing. So I had something else in mind, but I now forgot. Let's do one of me. Let's do a 30 seconds of me just thinking. Hmm. 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 What did I forget? Hmm. What did I forget? Huh. What did I forget? Now I'm really racking my brain. What did I forget? Okay, that's the short of me thinking. That will get a lot of attention, and that's really gonna become a short. I'm gonna cut it up and create a short after this. Yes. So Alex, yeah, my home lab setup is essentially a standard home network of 1 gigabit internal with a ubiquity switch, single one, and I have one server for everything, including so on that one server I have Kubernetes and my storage. But I also have a desktop machine which is fairly strong. This is what I use to stream here. So I created a VM on it and I run Kubernetes pods there as well. So I have containers on it as well to run. Then, so it's not that great of a home lab, like really not that great. I also have some cloud infrastructure, like who doesn't these days? Who does anything like home lab? Who doesn't have anything in cloud? Like, because why would you not run your website in cloud? So, oh yeah, I just remembered what I was thinking. Let's add at the end. Uh, I remembered. I'm thinking. I'm thinking. I just remembered. I'm so cringy. Let's try it again. This one, not enough pause before I started laughing. I'm thinking. I'm thinking. I just remembered. Now this was better. Um, yeah, I don't want to self-host my website because I don't want to deal with that on my own network. Simple as that. But so that's why I put it into cloud, because separate network completely, and I don't want to deal with that, like having problems with having a public website on the same network and getting DDoSed and bullshit like that. And hopefully YouTube won't. Oh, they can't because I'm not monetized at all yet. So, oh well, they won't put ads on it anyway. So, oh well. But I host my website in cloud, all my websites, and my Mastodon as well. So, any of you use Mastodon? If you are, you can follow me on there. I'm Bigpod at mastodon.bigpod.sc. Or if you actually don't want to remember it or type it in, you can go to bigpod.sc/mastodon and you will find my Mastodon. And bigpod.sc is actually my website. You can check it out and laugh at how bad my design skills are. Or let's laugh together. I'm gonna ensure that I can actually connect to it. Here we go. Let's laugh at it together. Make content. Sorry for everybody who got blinded. But yes, this is my website, and these are my design skills. So if we reload, you're gonna see how quickly it loads. Fairly slow. That is, and this is pretty fast because what I'm using is called Blazor. Blazor is technology in C# that allows you to write C# in the browser using WebAssembly. I'm a big supporter of WebAssembly for use in browsers, particularly. So, oh, I don't have a link to Mastodon. Guess that's an update to my website. Brain, remind me later to update my website for Mastodon link. But if you go to bigpod.sc/Mastodon, it should work. Now, on the sidebar, I also have a link to my blog. Problem, it doesn't point to my blog. It points to an API that doesn't have blog on it. But blog exists. Let's find it. Okay. I need to find the. Yeah. The best you do is the best you do, and blog.bigpod.sc. And you will see about my writing skills very quickly. Boom. 0 blogs written. Technically, there are 2 blogs. They're just not on a public site because they are demo blogs. Technically, they're also there. They're just not deployed. Like they don't show up here. If we actually could access the application itself, which I don't think we can. No, because it's compiled. You would see that there are two testing blogs already. Test 1 and test 2. That's the title. Hey, let's see. 1. Posts 1. Yep, those are the posts. That is the post 1. It loads, but there's nothing there because there is nothing in the post. Let's try post 3. There is nothing that says there is no post there. Yep, that's correct. And at least this link doesn't link to the right place. Good job, me. So yeah, this is my blog. I'll be writing about my experience doing container low-level stuff on that blog, so check that space out. I might actually make an RSS feed, maybe, but I will for certain do. I will make sure it isn't blindingly white. It will be blindingly gray. So not a reflector, just a meshed up reflector. So before I go for the ending stream part, are there any questions, any other information you would like to know about today's topic or future topics about containerization, Linux, stuff like that? Sorry, please let me know, and I will try to answer it. If there will be no questions in a minute or two, I will start the stream ending part, which most of you have already seen or still watching. And at this point, I'd like to say thank you to the person who liked my stream. It's highly appreciated. Oh, and I might actually do some posts on the communities tab. I'm gonna try that out as well. So we'll see how that works on YouTube. It's kind of a thing now, I guess, for me. Something new, so we'll try it out. So at this point, I guess, I see there are no questions in the chat. So I guess it's time for me to do the ending part. Thank you guys for watching the stream. If you haven't yet, remember to click that like button. It does actually make a difference for every YouTuber. Also, thank you for chatting with me. And subscribe if you haven't already. It is nice counter for someone especially that this size. It's nice to see it tick up every so often. And thank you for spending 1 hour with me, or however time you did. I hope you learned something, and you will join me again next time when I'll be doing something else low-level containerization. Maybe even write my own CNI plugin. We'll see. I'll see you next time. Goodbye.